In this video, we're going to learn how to calculate the pH of a strong acid. We're going to see that a strong acid makes this much easier than a weak acid. So remember, what exactly do we mean by a strong acid? Well, first of all, we've got to recognize a strong acid. And so this is from our textbook here. So we're going to say that you've got a strong acid if you are hydrochloric, hydrobromic, hydroiodic, or if you are nitric, perchloric, or sulfuric. So as soon as you see one of these 6 acids, you're going to start to think they must be strong. And what makes them strong is that they completely dissociate, they completely break apart. So this is HCl. So when HCl dissolves in water, it completely breaks down into hydrogen ions and chloride ions. So for every molecule that we add, we get an additional hydrogen ion and we get a chloride ion. Okay, now remember in water, right, so the hydrogen ion sits on the top of a water molecule and turns into the hydronium ion, so we can just write hydronium, whereas sometimes we should probably write H+ just to keep things simple. All right, let me go ahead and clear that away, and let's go ahead and get started. So the thing about a strong acid, remember, is that it undergoes 100% dissociation or ionization. So for instance, if you've got some hydrochloric acid and you want to know what's the pH of 0.1 molar HCl. First of all, you got to recognize that was one of the 6 acids we just looked at. And then you got to remember, well, since it is a strong acid, we don't have to write in equilibrium. We can write this essential 100% breakdown into ions. So it's 100% breaking down into hydrogen and chloride ions, right? We don't really need an ice chart. We can just immediately say if that is 0.1 mole per liter and it 100% breaks down, that's going to be 0.1 mole per liter and that's going to be 0.1 mole per liter. All right. pH is do you remember the definition? Yep, it's the negative log of the hydrogen ion concentration. And in this case, the hydrogen ion concentration is the concentration of the acid. It will not be throughout the rest of this chapter, actually. And it's a monoprotic acid, so that means it gives 1 proton off. And if you take the negative log of 0.1, you get 1. And your calculator, of course, lies because you have to know the number of significant figures. And this number turns into the number of decimal places. So 0.10 has 2 sig figs, so the pH would have 2 decimal places. So that would be 1.00. And again, the pH is less than 7, which is what we'd expect for an acid at room temperature. Now, do you know how to calculate the pOH of that solution? You can pause the video and maybe see if you can get the number. And the answer is at room temperature, the pH and the pOH add to 14. So if the pH is 1, the pOH would be 13.00. All right, here's another one. What would the pH of 12 molar HCl be? So can you go ahead and calculate that? Just pause the video and see what you get for that. Okay, we're going to unpause the video. So HCl is a strong acid, so we can assume it completely breaks down into ions. We know that if this is 12 moles per liter, when it breaks down, it will give us 12 moles per liter of hydrogen, and the same with chloride. The chloride ion, though, is not going to affect the pH in any way, so we can ignore. We find the pH by taking the negative log of the H+ concentration, which is 12, and if we do that on a calculator, we get something kind of interesting. We get minus 1.08. So 2 significant figures becomes 2 decimal places. And you might look at that and you say, well, hold on a second. I didn't know you could have a negative pH. And the answer is, yeah, you can. It's kind of unusual. Most of the time, the pH of an aqueous solution stays between about 0 and 14, but it is possible to have negative pHs. The pH scale has no limit. It can go from -infinity to +infinity. However, it is unusual to be outside of 0 to 14, but in this case here, it would have a pH that is exceptionally low. It's a very strong acid.